Unit 0, Day 3 notes. Okay, so we have a lot of definitions. You guys, this packet that we're doing with all these notes, there is a ton of vocabulary in here because remember our first day, all those vocabulary words you need to know. Today in Day 3, there are a lot of other vocabulary words you're going to need to know. I would keep this in a safe spot or rewrite them somewhere because you will use them throughout this year, okay? So, counterexample. Can I get somebody to read the counterexample for me? Okay, thank you.
Example that shows that a statement is incorrect. Example, all natural radius. Not example incorrect since it is a false.
Okay, so counterexamples just prove something's wrong. So if they give you a statement like all numbers are even, okay, well a counterexample would be what? 3, because 3's odd, right? Okay. Conditional. Can somebody read conditional for me? Thank you.
A conditional is an if-then statement. Example, if the figure is a rectangle, then it has 4 sides. Statements can be true or false.
So, everybody okay with that? So it's just your if-then statements. Okay. Hypothesis. Thank you. Okay, so hypothesis. So some of these things I would probably suggest. So we know that hypothesis is always the part, so it's after the if. Okay, so what they're saying is, see right here, after the if is a figure is a rectangle. So the hypothesis is a figure is a rectangle. Is that clear? All right. Okay, conclusion. Thank you. Perfect. So again, so conclusion is after the then. So if we go back here to the statement, after then, it has 4 sides. That is our conclusion. Converse. Do I have somebody to read converse? Thank you. So notice how on all if and then statements, it can be true or false. Because sometimes when you do the converse, it ends up making something that's not true. Okay? And so all they did was exchange your hypothesis and conclusion on the converse. All right. And let's go ahead and underline that part. Okay, biconditional. Thank you. Okay, so biconditional, okay, it's a statement that has if and only if. Okay, and the last one, definition. A definition is good if it can be written as a true biconditional. So 2 angles are supplementary if and only if the sum of the measures of the angles is 180 degrees. So whenever you have a definition, if it makes something true with if and only if, it's a definition if it works. Okay. So moving down, examples. Name a counterexample. So going back, counterexample means you're proving something's opposite, right? You're giving it a statement that proves it's wrong. So name a counterexample for all angles are acute angles. So right now in your groups, talk to each other. What would be a counterexample for that? All right, so who has one example of a counterexample?
An obtuse
Good. Obtuse angle is a counterexample. Did anybody think of something besides an obtuse angle? Yes. Very good. Right angle. Now, do you think that we would need to write both of these? No. As long as you have one example that is a counterexample, then that's fine, and you've proved that it's not a definition and it's false. Okay? All right, number 9. Given the conditional statement, if a figure is a parallelogram, then the opposite sides are parallel. So identify the hypothesis. So I'd like you to write what you think the hypothesis is. Okay, you should have put, so if we go back, hypothesis is the part after the if, correct? So am I going to write if in my hypothesis? No. So it's just the part after the if. So it is a figure is a parallelogram. Okay, identify the conclusion. I thought I had maybe messed up on the sketch. Sorry. Okay. So, did you guys get the conclusion? Anybody? Tell me what it is. Very good. The opposite sides are parallel. And did I give you enough time to figure out the converse? Okay, what's the converse? Perfect. That is exactly correct. So if a figure has opposite sides parallel, then it is a parallelogram. All right, so finish the biconditional statements to make a very good definition. Okay? So, an angle is a right angle if and only if what? Talk in your groups before you write things down. Okay, so what do you guys think? How do we know for sure something's a right angle? Very good. So it's if and only if the angle measure is 90 degrees. Do you have to write it exactly how I'm writing it? No, probably not. You probably could write something, but something that talks about that the measure has to be 90 degrees. Okay, so now for 10B, a triangle is obtuse if and only if what? Talk in your groups. What do you think? Okay, anybody want to share? Yes.
The triangle is an obtuse if and only if it is greater than 90 degrees but less than 180 degrees.
Good. Now, how many angles, in order for a triangle to be obtuse, how many angles need to be greater than 90 degrees? Just one, right? And so you might want to include something like that. So I put, okay, so a triangle is obtuse if and only if one angle is obtuse. Or you could put is if one angle is greater than 90 degrees. So like this could be interchanged, or you could put both of it into your definition. And so 10C, you are supposed to create your own. Make a biconditional statement. It can do with math or not do with math. So see what you can think. Talk about it in your groups. Try to come up with a different biconditional statement than what you have here. Do you think that you could wait until we're done doing notes and then I'll let you go? Okay. All right. Anybody think they have a pretty creative one that they want to share? Let's hear it.
Mine's green tea is green tea if and only if it's green tea.
Okay. Do we think that's a good one?
Yes.
What makes it not a great one?
It's not green tea.
No, that's not why. Because you're using your answer in in both parts. Do it make any sense?
So I have to use it only.
So that doesn't, so it's green tea if and only if it's green tea. But you would need to what makes it green tea? So, okay. Maybe you're right. Okay, anybody else have one that they think is better? Okay, let's hear it. That's good. And it's not good just because it's math. It's because it actually had a good definition. Okay, let's hear it.
The pizza is only, the pizza is good if and only if it is baked.
There you go. I think that works. Mine that I kind of came up with, but I don't know if it's great, was you will get a good grade in math too if and only if you come to class and do your homework. I don't know. Just going to throw that out there. We'll see. Okay. So you can write whatever you want to here. All right, moving on. Okay, so we have all these properties. You are going to use these so much when you're writing proofs. Okay, look through them. I'm not going to read all of them to you, but look through them and make sure that they make sense to you. And if they don't, then we need to talk about it. But my husband, he teaches biology at Sanger. And so they were in their class doing something, and he was talking about the reflexive property, like why things are the way, because what were they doing? I don't know. But anyways, this applies to science as well, just so you know. And yes, my husband and I talk about these things. I know it's kind of weird, but we do. So, you use substitution property a lot too in science when you're changing things, right? If you're converting from grams and, okay, I'll just be quiet. Okay, do we have questions about any of these? All right, let's move on. Now for the fun stuff. Okay, so if you look on the left side there, those are all the statements. They have basically done all the work for you on the left. Okay? Now we have to figure out what is it that they did on the right. We need to give the reason. Why were they able to do those things? What are the reasons? Which goes back to all of this stuff we just did, and specifically a lot of these definitions. Okay, so you're going to be flipping back and forth. And let's see here. Okay, so on number 2. How can they write that statement? And it goes back to that page, and then it also goes back to like the vocabulary words from day 1. So whenever you have how they were able to write this equals 180, what things equal 180? You said it. That's the answer. Definition of supplementary angles. I think if you just had supplementary angles, I think that would work. This is how you abbreviate angles. You guys remember that from last year? So you make like a little angle sign. If you even just put angles like that, that also works. But normally you do that line showing that you're talking about the degree of the angles. Okay, so does this make sense? Why? So it's saying that this angle AOM plus MOC, when you add those two angles together, it equals 180 degrees. And that is definition of supplementary angles. Okay? All right, number 3. So what did they do now? They changed AOM to 2x plus 3, and they changed MOC to be x. So what is that? That's it. It is substitution. And you could put substitution property, or we could just do substitution. I like that better. Okay, what did they do next? Exactly, they combine like terms. So we're just going to write that, combine like terms. Okay, step 5, what happened? How did they move the 30 over? What did they do? It is subtraction property. I don't know, again, we might not have to do subtraction property, but I'm just going to write it for now. Okay, and then the last thing, what did they do? Divide, which we would call division property. So that's not too bad, right? Okay, questions there? All right, moving on to 21. So again, this should hopefully be a review from Math 1, if you guys remember. Okay, so if lines are parallel, then alternate interior angles. Okay, first of all, what does alternate mean? Opposites. And interior is inside. Okay? Then alternate interior angles are congruent. Name 2 pairs of alternate interior angles. So, in your groups, discuss which ones are the alternate interior angles. Okay, so inside angles are these 4 and 3 and 5 and 8. But alternate interior angles, because we're saying they're congruent, which means they're equal. Are 4 and 3 equal? No. Good. So it should be 3 and 5, and 4 and 8 are your alternate interior angles. So again, I'd write this as angle 3 and angle 5 is one pair. And then your other pair is angle 4 and angle 8. Okay, 21b. If lines are parallel, then corresponding angles are congruent. Okay, well, what is corresponding? What do you think corresponding means? Corresponding means that they're in the same spot, but just on the other parallel line. So they're congruent if they're in the same spot, but on the opposite line if the two lines are parallel. So what would be a pair of corresponding angles? 3 and 7 is a pair. Good. What's the other ones? Good. So see how 4 and 6 are in the same spot but on different lines? Those are corresponding angles. That means that 1 is corresponding to 1 corresponds to 5. 2 corresponds to 8. 3 corresponds to 7. So they're on the same spot, different lines. Okay? So we'll write down 2. I'm going to write angle 1 and angle 5. And then another one we can do is angle 3 and angle 7. Okay, 21C. If lines are parallel, then alternate exterior angles are congruent. So first of all, just tell me what are the exterior angles? Which numbers? Very good. 1, 2, 6, and 7. Those are on the outside. And alternate means opposite. Okay, so what would be 2 pairs? Or what would be 1 pair? Good. 1 and 7 is one of them, and the other one is 2 and 6. Are there any other observations you notice? One of the things that I wrote down was that angle pairs are congruent. What do I mean by that? Like 1 and 2 are congruent with 5 and 8. 1 and 4 are congruent with 5 and 6. So maybe we can write that down. Angle pairs are congruent. Anybody notice anything else? Okay. All right, number 13. I'm not sure what happened there. Okay. So this next part. Parallel lines and triangles. So the postulate is through a point, not on a line, there is one and only one line parallel to a given line. And we're going to prove the theorem that the sum of the measures of the angles of a triangle is 180 degrees. So moving down, given triangle ABC, here it is, and we want to prove that measure angle A plus measure angle 2 plus measure angle C equals 180 degrees. So again, they gave us all the statements. We now need to give all the reasons. Okay? So draw PR through R, and it's parallel to AC, and so here's this line AC, and then we're drawing 2 lines up to a point on that line, okay? Angle PBC. So here we go, P to B to C. So that's 1 and 2, right? And 3 are supplementary. So what is that? What do you think that reason is? Anybody? So I'm looking back at my vocabulary sheet. If you notice, those 3 end up making what? Those 3 angles, or the 2 angles and the 1. So this angle, the 1 and 2 together, plus the 3 make a linear pair. So that we'd write here is that angles that form a linear pair, if I can spell, pair, are supplementary. So what happened is that we took this and this, so those are the angles, they form a linear pair. Linear pairs are supplementary because anytime you have two angles that make a line, they're supplementary, right? Okay. Now, what do you think 3 is? So basically, they've taken the same information again, right? That's exactly it. It is the definition of supplementary angles. Okay, and you don't have to write definition if you don't want to, but I'm just going to put it here. So definition of supplementary angles. So on 4, it says measure angle PBC, so here's P to B to C, is actually equal to the measure of angle 1 and plus the measure of angle 2. So going back and looking, what are they talking about there? So go back to your vocabulary words. On the first page, Math 2 vocabulary. We're talking about angles. So I'd go through my definitions, looking at the angles, and see which one I think kind of fits. What do you guys think? No, but I think that's a really good guess. So you have two angles that are being added together to equal another angle. Angle addition postulate. Okay, now look at number 5. What are they doing to number 5? Okay, so do you see on 3 we talked about how that's a definition of supplementary angles, right? Then they're like, okay, we know that this angle is this one plus this one, right? So then when you get to this line, they ended up taking out the PBC and putting in the measure angle 1 and measure angle 2. So do you see how these match, but they just took out the angle PBC and put in measure angle 1 plus measure angle 2. So what is it that they did? Substitution property is exactly it. Okay, so let's look at 6. It says angle 1 is congruent to angle A. Angle 3 is congruent to angle C. We just kind of talked about some of that. What is that? What is it? Close, but no. No. We kind of did this back where, oh, I right up here in 21. So see how you have 1 and A? It's kind of like 4 and 8. Do you see how you have 3 and C? See how 3 and C? Alternate interior angles are congruent. So you could just put alternate interior angles, but I'm going to put are congruent since it's talking about them being congruent right here. Okay. Now, when it says measure, it's basically talking about the specific number, okay? And so what happens is, because you have this, you can then come to this because of the definition of congruence. So if they're congruent, then they are equal. Okay, and then the last one, it just goes back, so it went from here to here. They just end up using the substitution property again. And basically, the more that you do these problems, the easier they will become, and then a lot of these things you'll start remembering.